Hello everyone. So this video is the continuity of the last video. So if you didn't watch the last videos, go watch at least last 3 videos and come back here. So in the last video we have been seeing that we can take this pin mode out of this void loop and we can bring it inside the void setup. Why? To avoid unnecessary calling of this function, to avoid unnecessary implementation of this line, because only one time of this line is enough for us. Okay, only one time. Okay, for each and every pin, saying only one time of pin mode is enough. That means we don't need to repeat again and again like we are repeating the digital write. Okay, so unnecessarily we are re-saying again and again 3 is output, 3 is output, 3 is output, 4 is output, 4 is, you get it, 3 4 5 6 7 is output if you say one time enough, but we again come to the void loop and say 3 4 5 6 7 output. No need. Okay, so we will take it out. Okay, I'll take the pin mode part out and I'll bring to the void setup, because normally we do the pin mode in void setup because one time is enough. Okay, so one time we are going to say, look at this. Okay, pin number 3 is output. Okay, then again we are saying 4 is output, 5 is output. I will change the values. 6 output, 7 output. Okay, 4 output, 5 output, 6 output, 7 output. This will work. Now in the void setup, one time we have said these things, so everyone knows these pins are output. Then only the functionality has to be repeated, not the setup has to be repeated, because saying one time is enough. But switching on should be repeat, switching off should be repeating. Okay, because every moment we switch on and switch off, we switch on and switch off. But saying output, we never change. We never say remove the output again add the output. No, only saying one time output, that's output always. Okay, so we can do this. This will work. But again, we can. You got it right? You got the thing. We can do it inside the. We can write it here also inside the for loop, because I am repeating the pin mode again and again. I mean all these 5 lines I can implement using a for loop. Okay, inside the void setup itself. Okay, one time that for loop will run, that will say each of the pin output only one time. We are done. Then the for loop will not run, because void setup will come out. We will come out of the void setup and we will get into the void loop and repeat. You get it? Okay, so let's write the same for loop is enough, right? Because the same number of values are changing. So I can copy this. So I hope you can catch up with my pace now, because we have seen the same scenario again and again. Okay, and I will what should I say? Pin mode, because I have done the same a little bit before in the one of the previous videos. Okay, pin mode IE output. Pin mode IE output. Okay, so now we will see in no time, okay, without any delay, this for loop will make output pin number 3. Then next for loop will do pin number 4 output, pin number 5 output, pin number 6 output. The final for loop iteration will happen with pin number 7 output, and then I become 8 and for loop will exit. Then void setup will exist and we will get into the void loop and we will forget the void setup. Okay, so this for loop is enough. That means this for loop is equal to writing all these 5 lines. Okay, so I will remove those 5 lines, and we have done a magnificent very beautiful code refactoring. Okay, we have decreased a lot of code redundancy actually. Okay, there's no unnecessary code here now. Okay, but one thing is, for the void setup also we have to mention integer as I. Why? Because here we mentioned integer as I inside this void loop. Our declaration have happened inside the void loop, so this variable is only for this block. This is a local variable. Okay, so I have explained you the local variable and global variable scenario in one of the previous videos, earlier videos. You can go and watch it if you want. Search in the playlist and watch. Okay, so this I is only available for this particular block. Okay, void loop. But for void setup, if you don't declare an I, void setup doesn't know what is I. We never declare the variable, because the declaration happened inside the void loop. Okay, so what I will do is I will say int I here. I will declare the same another I value inside the void setup. So this I value is a local variable for this block. Okay, it is like having the same let's say a person named as Jack. So this is one house. In this house there is a there's a son, his name is Jack. Again in this house there is a son, his name is also Jack. Okay, but they are in two different houses, so there is no confusion. So if you say Jack here, this Jack will be used in this house. If you call Jack in the other house, this Jack will come. So no problem, right? You can have the same variable name. So if it is confusing, you can use a different variable name, J, and you can see for J is equal to 3. It's just a variable name, guys. Okay, J is less than 7, J plus plus. You can use any name, A, B, C, D, C, counter. Maybe you cannot use a keyword, except that you can use any variable name. So J, nothing wrong. Okay, you get it? Okay, for the moment I will keep it as I, because now you have some understanding about all these things, because we have passed more than 100 videos about Arduino. Okay, so I will keep the same name. So this is one I. Here being used is another I, because they two are different homes. Okay, so having same name of a person, having person with the same name will not make any confusion, because two different houses we are going to use within their houses. Okay, only because this I will be used for this for loop, and this I will be used for these two for loops. Declared values will be changed. Okay, so this is Jack for this house, this Jack is for this house, so no confusion will happen. Okay, this is so clear, right? So let's come to the topic. So you can watch and local global variable videos from my playlist, or you can check it anywhere you want. You will be understanding. If this is still confusing, you can just change the variable name, and here also you can change the variable name. Okay, here you can keep I, no problem. Okay, so now what are you doing? Okay, fine. From the last demo, what we have done, we have found out, okay, the switching on for loop, even we iterate again and again with the void loop, we found the switching on scenario cannot be seen after one iteration of the for loop, of the void loop. Okay, after one complete iteration, in the second iteration we cannot see, because we didn't switch it off. So we did a switch off scenario. Okay, then we found this pin mode thing is unnecessarily written inside the void loop, therefore it is repetitively running during each and every void loop iteration. So we brought the pin mode inside the void setup. Okay, and also we refactored it using a for loop here as well. So that for loop will run 5 times. That means one complete iteration of the for loop will happen. So all the pin mode values will be assigned. Then we'll come out of the void setup, and we will do the void loop functionality. This is all we had to do. Okay, now let's see, according to our logic, what should happen. Here we set all the pin modes, nothing to worry. Here we come and switch on all the LEDs one after another. Okay, first iteration, one after another with 400 millisecond we switch on. First LED switch on, 400 millisecond delay. Second LED, 400 millisecond delay. Likewise, until fifth LED with 400 millisecond delay, we switch them on. Then once the fifth LED is switched on, this for loop will break, and we will come into the for loop, and we switch off all the LEDs at the same moment. Okay, we switch off all the LEDs at the very moment. Then once all the fifth LED is switched off, I will become 8, and all the 5 LEDs are switched off at the same moment. Then I will become 8, and we will exit the for loop. We will come here, and we will repeat again. When we are repeating, now all the LEDs are switched off. Okay, again we will switch on the LEDs one by one with the 400 millisecond delay, and again we switch off. Once everything is switched on, after the 400 millisecond, we again switch off everything at the same moment, and we will repeat. You get it? Let's check it out with the demo. I'll take the code. Okay, and I will do a simulation. Let's see. 1 2 3 4 5. Everything is off. 1 2 3 4 5. Everything is off. 1 2 3 4 5. But still you might find a small difference here, small issue here. We will have a look on this in the next video, guys. Just follow me up.